Now let's get into a couple other new identities. Sometimes we refer to them as the power-reducing identities and the half-angle identities, both of which are particularly useful in very, very specific situations, which I wanted to get to as well. But let's just discuss why they are true before we use them, as always. So the power-reducing identities, or as this source says, formulas for lowering powers. But I often call them power-reducing identities, which it says in the cheat sheet that I'm giving you guys. But basically, what it says is that the sine squared is equal to 1 minus cosine 2x over 2. Basically, what this one is saying is that if I have a sine squared, I could lower its power into a singular cosine of a double angle. Or if I have a cosine squared, I could lower that, basically change a square into a non-square. And really, these are true exactly because of the cosine's double angle identity. Because notice that in this identity, we prove the connection between cosine of 2x and sine squared and cosine squared. Well, if I take each of those identities and solve them for the square, I'm going to get the power reducing identities, which is actually very, very easy. So let's go ahead and do that. But if I start with the fact that cosine of 2x is equal to 1 minus 2 times the sine squared of x, version 2 as I called it in the previous video. Basically, if I just solve for sine squared, I could subtract 1 from both sides. And I could divide by negative 2 in order to cancel out the coefficient. And that would leave me with sine squared x is equal to cosine 2x over minus 2. And if I just go ahead and distribute the denominator, that would be cosine of 2x divided by negative 2. And remember that 2 will not cancel, as I was saying in the last couple videos, because it is within a trigonometric function. It is not multiplied. So that's a mistake I've seen students make quite a bit, is canceling 2's here, but these will not cancel. And then that's also, of course, in the secondary term, I have negative 1 divided by negative 2, which is plus 1/2. Or another way I could organize that would be, well, I have 1. This is just a negative term, and I have a common denominator. I could even factor out the 1/2, and that would leave me with 1 minus cosine 2x. Because really, this is positive 1, if I factor out the 1/2, and this, if I factor out the 1/2, I'd be left with a negative. Positive or negative is negative, so I have negative cosine 2x. This is a very common way I've seen this identity written in books, or as it is presented in your packet, it is, if I distribute the 1/2, I get 1/2 minus, I have a common denominator of 2, right? So this is exactly equivalent to writing it this way as well. But essentially, the conclusion here is that I can take a sine squared and lower its power to a 1/2, the difference between 1 and a double angle. Which these identities are much less useful in general, but these are actually quite useful in calculus, specifically Calc 2, for doing various things like when you're talking about integration. Finding the integral of a square function is a very difficult idea using basic tactics. But if you lower its power, it's kind of a workaround. It's a simple alternative approach, and it's just kind of simpler in some regards. But essentially, some of these identities that we're talking about are not exactly things I'm going to test you on, because it's kind of hard to use them now. But they are useful later, which is why I'm bothering to explain them to you right now. Also, another thing I wanted to just mention real quick is that we're talking about a lot of identities, and there's the cheat sheet that I forget if I've mentioned this to you guys before, but I'll go ahead and do it now. But basically, the cheat sheet is something that I'm going to allow you to use on the final. And it's basically has all of these identities. So we've talked about so many identities, it's enough to probably make your head spin. And a question that probably a lot of you have been wondering is, do I need to memorize all of these identities? And If so, how would I even go about doing that? So I'm trying to find my cheat sheet over here. But basically, what I've done is I have kind of, when I first started teaching trig, I compiled a giant list of all of the identities that we covered and put it all in one place, just as a way to kind of, instead of having to look through the book and try to find things, put it all together. Now, usually I don't allow my students to use this on their tests, but I give it to, usually what I'll do is I'll print this out as just a reference page so that, say you're in calculus and you're trying to remember something and find a particular rule or identity that we covered, it's kind of it's nice to just have it all in one place. And I'm sure you could find a similar reference page, in a bookstore or something. But just anyways, I made one myself and I've kind of been updating it over the years. But basically, on this cheat sheet, I will let you use it on the final, because we're online right now, and usually I wouldn't. But anyways, in addition to the one page of notes I'm going to give you guys, I'm also going to let you just use this. That way, everybody has the same resources, and I'm not making you memorize all these things. Because at the end of the day, when we're looking at all of these identities, there's so many formulas. It's easy to mess them up. And so I think it's a fine concession. Anyways, but on here we have the basic unit circle, which is something that I expect you guys to memorize, but since we're online, it's kind of hard to impose that restriction. But basically, we also have SOHCAHTOA, the right triangle definitions. I even put the range of the inverse functions on here as well, which we talked about back in 4.8, but it's kind of a tricky thing to remember when we're trying to use inverse functions. But notice that on here, we have a lot of the fundamental identities, even and odd, Pythagorean, and then here we've got a lot of the identities I've been proving exactly right now. Some difference identities, periodic identities. Actually, we didn't really talk about these, but these, we talked about coterminal angles and the fact that, well, if I add 2 pi to it, it's going to be coterminal, so it's going to give me the same thing. But basically, we got our cofunction identities. Some stuff down here that actually we're not covering in this class because we don't have enough time. But there, there's some interesting trigonometric applications in more advanced mathematical subjects like complex analysis, which are nice as well. But basically, on the right-hand side, we've also got our half angle, power reducing, those are the ones I was just kind of talking about in this video, double angle identities, and a few others that we will finish up with in the next video. And also law of sines and cosines. So you don't need to memorize those either from last week because they're on the cheat sheet. Just as another thing to notice. Anyways, that will wrap up this video. In the next video, I'll talk more about the half angle identities, and we'll also get into how do we actually use these to do anything helpful.